This is the video on chapter 38, the mean value theorem. And we have a function from the closed interval AB into the reals. And our function is continuous on the closed interval AB and differentiable on the open interval AB. Your function could be differentiable everywhere, and a lot of the examples we look at, our functions are just plain differentiable everywhere on the reals. But the minimum requirements, we need it to be continuous on the closed interval AB and differentiable on the open interval AB. And if that's the case, then there is some place in the interval, there's some C in the interval AB where f prime of C is f of B minus f of A divided by B minus A. Let me talk a little bit about what that means in terms of a rate of change. F of B minus f of A divided by B minus A. This is the average rate of change of f over the interval AB. And so what we're saying is that there is some place in the interval where the instantaneous rate of change, that's f prime of C, is actually the average rate of change. Think about what this would mean if you were driving. So suppose you drive someplace. You're in a car, it's sitting still. You start the car up, you drive. You're driving down the road. You look at your speedometer, you're going 60 miles per hour. Now let's assume that for the whole time you've been driving, your speed's been between 0 and 60. Your average is somewhere between 0 and 60 miles per hour. At some point in time in your journey, your rate of change was that average rate of change. You could not have been driving less than the average rate of change the whole time, or greater than the average rate of change the whole time, or else the average wouldn't be the average. So at some point in time, your speed was your average speed. That's what this is saying, that at some point, the instantaneous rate of change is the average rate of change. This is a corollary. It's a corollary to Rolle's theorem. Rolle's theorem says that if f of b is equal to f of a, then at some point the derivative is 0. So the mean value theorem is a corollary to Rolle's theorem. There are two important corollaries to the mean value theorem, corollary 303 and corollary 304. Corollary 303 says if a derivative of a function is 0, that function is constant. Corollary 304, which is a corollary to 303, says that if two functions have the same derivative, then they differ by at most a constant. These are going to be important theorems when we get to the section on antiderivatives and indefinite integrals. What I want to do for the rest of the video is look at example 305. I'm going to do a version of it. I'm going to do a little bit more than what is required in the notes. So in the notes, we're given this equation, and our directions are to prove that this equation has at most one solution. I'm going to show that it has one and it has at most one. So we're going to show that this equation has a unique solution. So how do we show that it has a solution? We're going to use the intermediate value theorem. So we set f of x equal to this polynomial. And so what is our goal? Our goal is to show that f of x equal to 4 has exactly one solution. Well, we have a polynomial. Polynomials are continuous everywhere, so the intermediate value theorem applies. So we substitute 1 for x, and f of 1 is equal to 3. Then we substitute 2 for x, and f of 2 is equal to 42. And 4 is between 3 and 42. So the intermediate value theorem implies that there is some number c in the interval 1 to 2 such that f of c is equal to 4. And so there is a solution by the intermediate value theorem. So now we want to show that there's only one solution. For that, we're going to use the mean value theorem. So what we're going to do is we're going to suppose there are two solutions and get a contradiction. So let's suppose we have f of a is equal to f of b is equal to 4 for a and b with a less than b. If there are two different numbers, one smaller than the other, so we're going to assume a is smaller. By the mean value theorem, there's a d such that f prime of d is f of b minus f of a divided by b minus a, which is 0 because f of a is equal to f of b. we could use Rolle's theorem here as well. Because we're assuming f of A and f of B are the same, Rolle's theorem says that there's some number in this interval where f prime of D is equal to 0. So we could use Rolle's theorem here as well. However, what is f prime of D? Well, f is a polynomial. Polynomials are very easy to differentiate, so we calculate the derivative, we substitute D. What happens then? F prime of D, 5d to the fourth plus 3d squared plus 1. This is an even power. This is an even power plus 1. This expression is greater than or equal to 1, which is strictly greater than 0. This is our contradiction. Because the mean value theorem says someplace a derivative is 0, but the derivative can never be 0. So this is our contradiction. Therefore, no such A and B can exist. In other words, there cannot be two different solutions to this equation.